Hi, I'm Wieland.
Hi, and I'm Sebastian Hubenschmid, and we will present the paper RELIVE, Bridging In-Situ and Ex-Situ Visual Analytics for Analyzing Mixed Reality User Studies. RELIVE is a joint effort between the University of Constance and the University of Maryland. And this work was done by me, as well as Wieland, Daniel Immanuel Fink, Andrea, Johannes Zagermann, Niklas Elmqvist, and Harald Reiterer. So conducting mixed reality studies often results in a lot of data. And while there might be traditional measurements such as task completion times, there are also often more complex metrics that, for example, characterize participants' movements, their spatial arrangements, or collaborative workflows. This can lead to rather complex analysis procedures. And in this regard, prior work has shown two different approaches. So some works use a non-immersive approach and, for example, use a desktop for data analysis, which often excels at an ex-situ analysis as there is a rich ecosystem of well-integrated and cross-compatible applications. In contrast, recent works use an immersive approach, for example by visualizing data with augmented or virtual reality. This approach is often ideal for an in-situ analysis, as the immersion can be beneficial for investigating the environmental context and also offer better spatial understanding. We argue that an analysis workflow for mixed reality user studies can benefit from both approaches, depending on the current goal. However, researchers have to reconstruct their workspace when switching between these two approaches, preventing any kind of serendipitous findings that might occur if this transition between these two approaches was seamless. This makes the use of hybrid user interfaces or transition interfaces rather important, which can allow users to easily switch between these analysis approaches as needed. So to take full advantage of both an immersive and a non-immersive analysis approach, RELIVE combines an immersive VR view with a non-immersive desktop view. Since we use these completely different devices with complementary characteristics, RELIVE represents an asynchronous hybrid user interface, where these devices are used in sequence rather than simultaneously. And as a result, RELIVE has a desktop interface suited for a holistic ex-situ analysis, where users can investigate aggregated study data. Alternatively, researchers can also put on a VR headset and relive an interactive spatial recording of a study. Both views are instantly synchronized, allowing researchers to switch between desktop and VR as needed, allowing for a seamless analysis. So let's first take a look at RELIVE's desktop view. Here we combine the concepts from a computational notebook with a video editor interface. And similar to a computational notebook, we can create new configurable tools in the center panel. So for example, here we measure the distance between two handheld tablets that were used during a study. We can add different sessions from this particular study by dragging in more data from the left panel to compare this metric across different participants. So now each line represents the distance over time between two tablets in one study session. Similar to a video editor, we can also look at media data and show video recordings from the study or look into a 3D scene replication of the original study environment. We can control the playback of this media data with a timeline interface in the bottom panel. Here we can either play back the study as it originally happened or scrub back and forth for a specific point in time. Lastly, we can also explore the 3D scene replication by moving the camera around with our mouse and keyboard. Here we can use different perspectives, such as an isometric view from above or the viewpoint of a specific device.
But of course there are cases in which viewing this non-stereoscopic 3D scene view does not provide the full picture. And here our VR view comes into play. So simply put on the headset and with that we switch to a fully immersive representation of the original study scene. This environment is automatically synced with the desktop counterpart and provides corresponding in-situ visualizations like a 3D trail visualizing the participant's movement or a measuring tape showing the distance between two entities. We also have access to the same features as on the desktop. So for example, we can rewind, fast forward, or also directly jump to a specific point in time using the timeline panel. And attached to our left controller, we have another panel that allows us to add new visualizations or also modify existing ones. For example, here in the video, a frustum visualizer is attached to both tablets to highlight their field of view during the study. Yeah, and because of these 3D visualizations in stereoscopic 3D and the environmental context, we think that the VR view is especially helpful for an in-situ analysis to gather more insights into participants' behavior. So depending on the task, we can either work in VR for an in-situ analysis or use the desktop view for an ex-situ analysis. And since the application state is automatically synced between both views, this allows for an easy transition. So any change that is made in VR is also instantly visible in the desktop view and vice versa. The 3D scene window of the desktop view further supports this transition as it provides a preview to the VR scene and also allows for a quick peek into the in-situ analysis without having to put on a VR headset. To validate our findings, we evaluated RELIVE in a two-step evaluation process. So we first conducted an internal design walkthrough as a formative evaluation and then used the results to further refine our initial prototype. Next, we conducted an expert user study where we invited 5 researchers from different labs, and all of them had prior experiences in conducting and evaluating mixed reality user studies. With our study, we focused on 3 different research objectives. The first objective dealt with our chosen task allocation. Here, all experts agreed with our intended distribution of using a desktop view for an ex-situ overview of the data and a VR view for a detailed in-situ analysis in the environmental context, so akin to an overview and detail approach. For the second objective, we looked at the interplay between the in-situ and ex-situ analysis. Here, the synchronization was found to be essential for this kind of asynchronous hybrid user interface. However, for some participants, we also observed a loss of orientation and switching between desktop and VR, which could, of course, be further investigated in future work. As a third and last objective, we looked at the general applicability of RELIVE. Here, all experts were quite positive about our RELIVE framework and also saw great potential to use RELIVE for a collaborative analysis of MR study data. Finally, we gathered our findings as design insights and research implications, which you can read in more detail in our paper. And with this, we hope to inspire more research into the use of asynchronous hybrid user interfaces. For more details on our work, have a look at our paper, and you can also find RELIVE as an open source project on GitHub.